All right, so draw a right triangle. And it's the one about the boat being reeled in to the dock. So kind of imagine like the winch on the dock is up here and the boat is down here in the water. All right, it says the rope is 20 feet long. So what part of the triangle is going to be the rope? The hypotenuse. So this is the 20 right there. What is the angle of elevation? All these are going to be asking for the angle, which means your units are degrees. And it seems like a tiny thing to put that little degree symbol in, but that's your units. And I will take off if you don't put that, like half point, but still put that. And the boat is 16 feet away from the dock. So where does the 16 go? Yeah, this is the dock. So like the boat's out here. This is the water. This is the dock up there. So if the boat is 16 feet away, your 16 is going to go down there. So then you decide sine, cosine, tangent. You have adjacent and hypotenuse. Bless you. So which one is that? It's cosine. So cosine of x equals 16 over 20. And then how will you type that to get your answer? It's well said. Inverse cosine. A lot of people say second cosine, which is fine too. That's the buttons you're pressing, but it is an inverse, which is the whole point. That's what this unit is on, is inverse trig functions. You need to do 3 decimal points. And again, put your little degree symbol in there. If you were absent last class, that's all we did. It's not new. We've done it before. All right, so go ahead and draw another triangle. So, yep, just have an imagination here. A man is standing 22 meters away from a building. So where is the 22? The adjacent, the bottom part? Because this is the building and then this is the guy out here. The building is 58 meters tall. So 58 is the vertical part, the opposite, the height of the building. What is his angle of elevation? So X goes there. So is that sine, cosine, or tangent? It's tangent. Oh, you did find yours. I thought you said you didn't have it. Good job. Oh, okay. Oh, that's right. Good. See, you're all set. All right, so opposite over adjacent. And so you're going to type tangent inverse 58 over 22. And again, do 3 decimal points and put your degree symbol. All right, so one more of these. So a child looks down at his friend from the top of the jungle gym. So one kid is up here, one kid is down here. So like this is one child at the top of the jungle gym. This is the other one down here on the ground, right? Looks like he's floating, but just imagine a jungle gym. It says find the angle of depression, but that is the angle of elevation. Remember, ground and sky are parallel. So just always put your X down here. It says the jungle gym is 15 feet tall. So 15 is the vertical part, the opposite. And then I was kind of silly about this. I was trying to get like one of each of the trig functions. I wrote they are 17 feet apart. So if one kid's here and one kid's here, if they're 17 feet apart, I meant for the 17 to go there. I didn't put one that ambiguous on the test. I was just trying to make one of each of the 3 trig functions, because which is this going to be? Yeah, that's opposite and hypotenuse, so it's sine. I was just trying to make one of each of the 3 is what my goal was there. It's hard to get a hypotenuse in there. The only times you have that is if you have like a kite string or a rope connecting things. You usually don't know what the hypotenuse of a triangle is. All right, so that would be sine of x equals 15 over 17. And then go ahead and type that in. Oh, no, I just did that in the notes to review that because like that'll be on the final. But no, it'll be just like this. This unit is short and sweet. I like this one. All right, now let's go flip back and we'll do the front page. All right, so this is just which quadrants are they allowed in? The odd ones are in which 2? Odd is which 2 quadrants? 1 and 4. Okay, and so somebody said sine. I agree. So sine is in 1 and 4. Which other ones are odd? Yeah, I like when people say it that way. It's all of them except cosine and secant. So these are all 1 and 4. And then secant and cosine are even, so they are in which two? 1 and 2. Yeah, I made that worth points on the test. We spent a whole day just on that because you have to know that in order to do this next part, because if you don't know what quadrant to draw your triangle in, then you're out of luck for the entire problem. All right, so this one says arc sine, it's either in 1 or 4, and it's negative, so it'll be which one? In 4. So draw a triangle in quadrant 4. And I'm going to say this for everybody. If you did this, I'm not picking on you. I just don't want it to happen again. You have to draw the axes, not just the triangle, because I can't tell what quadrant it's in if you don't have axes. So please draw those for me, right? Sine is the y value, so that's where the -1/2 goes. Other side, square root of 3 over 2. And so what's your angle across from -1/2? Pi over 6, perfect. But your answer is not pi over 6. And you should write pi over 6 in that. That is correct. Reference angles by definition are positive, but your answer is going to be what? Negative pi over 6, because you went backwards. You're just going to practice that like a whole mess more times. That's really all that there is to it. All right, arc cosine, it's either in 1 or 2, and this is negative, so 2. Cosine is your x value, so that goes down here. Other side is 1/2. So once again, across from the 1/2 is pi over 6. Your answer is not pi over 6. It's how far you rotated to get there. So what is your angle in the second quadrant that has the 6? Good, perfect. 5 pi over 6. Keep calm and know the unit circle. This one's kind of tricky because the 1 makes you think of the circle. But when it's tangent, you're still going to draw a triangle. It's in quadrant 1 because it's positive. What are the sides so that you can end up with 1? Yeah, good. Perfect. Because anything over itself is 1. And so what's your angle? Yeah, pi over 4. Perfect. And when you're in quadrant 1, whatever you get just is your answer. Because you haven't rotated far enough for it to be anything different. You didn't go backwards or anything. All right, what quadrant is this one going to be? First, it's positive, so quadrant 1. In fact, bless you, we've done so many of these. Some of you might be at the point where you can answer this without a triangle. I still need you to draw the triangle because the triangle is your work, showing your work, all right? So sine is the y value, that goes here. Other side's 1/2. What's your angle across from square root of 3 over 2? Pi over 3. And when you're in quadrant 1, that's your answer. Bless you. All right, when you see an arc secant or secant inverse or cosecant, what you want to do is flip it over. Which one is your reciprocal for secant? Cosine. And then your reciprocal of -2 is -1/2. So rewrite it that way, and then that makes that a whole lot easier. It's negative, so which quadrant are we in? 2. Good. Draw your triangle in quadrant 2. Thank you. All right, cosine is the x value, so the -1/2 goes for x. That means the other side, square root of 3 over 2. What's your angle for that one? Pi over 3. But your answer is not pi over 3. It is how far you rotated to get there. So what's your angle in the second quadrant that's thirds? It's 2 pi over 3. Are you okay? Like whenever it's in the second quadrant? Well, if it's in quadrant 4, your answer is just going to be negative. It's whatever it is except negative. You just went backwards. If it's in quadrant 2, bless you, your only options are 2 pi over 3, 3 pi over 4, and 5 pi over 6. Those are the only ones that are in this section. Remember when you fill in the unit circle, those are the only ones that are over there. Those are the only options. Just remember, you don't have a whole lot of choices, which is what I think is great about trig. Your options are so limited that if you get stuck, you can guess your way out of it a lot of the time. Yep, yes, the denominator just matches. That's it. And we've done this so much that like you're gonna get it. You're gonna be fine. All right, what quadrant is this one in? Quadrant 1. It's positive, so quadrant 1. It's your square root of 2 over 2 triangle. And so your angle is pi over 4. And if you're in quadrant 1, that's just your answer. And again, we might be getting to the point where some of you are able to just answer that without a triangle. I get that. Draw a triangle anyway. It's your work. All right, we'll do a few more and then I will give us a break here because I know it's kind of a lot. All right, this one's tough. I hope that your initial instinct is, hey, wait, that's not on the unit circle. I hope you're like, hey, hold on a second. Off to the side, like a margin problem, I'm going to rewrite this as -1 over square root of 3. And let that sink in a second. Do you see how I unrationalized it? Like if you rationalize this, you would get this. All right, you're just going backwards. And then what's the next thing I told you to do with that? Yeah, good. Put them both over 2. Because now you're back to 1/2 and square root of 3 over 2. So now you're all good. All right, what quadrant is this in? It's negative, so it can't be quadrant 1. 4th, good. Tangent is y over x, or opposite over adjacent, however you want to think of that. So the -1/2 is the y, square root of 3 over 2 is the x. So what is that angle? It's pi over 6. So you write pi over 6 there. Your reference angle should always be positive. That's kind of a definition thing. But your answer is -pi over 6. So again, in quadrant 4, it's just whatever you got except negative. You just went backwards to get there. All right, we'll do a couple more here. Do you see how this is cosecant? Which is your reciprocal of cosecant? Sine. So you want to write it as arc sine. Now, if you flip square root of 2, you get square root of 2 over 2. I can go through that if you want, but it gets really messy. It's going to have to be square root of 2 over 2. It's the only one that makes any sense. Okay. What quadrant are we in? First. And we're going to do this to show our work. I know you're probably like, we've written the same thing a million times, but that's your work. All right. And then your answer is pi over 4. So this is another one where I would write this off to the side in the margin. I would write that as negative square root of 3 over 1. Anything you can put over 1. Any number is itself over 1. And then do the same thing you did with this one, just put them both over 2. So what quadrant is this in? It's negative, so it can't be quadrant 1. So where are we? Quadrant 4? Now, cotangent is x over y. So I know the negative looks like it's with the square root of 3 over 2 here, but you can put it with either one. It's going to end up needing to go with the -1/2. It's going to have to be the -1/2 because this is x over y. So it's going to have to be the square root of 3 over 2 goes there, -1/2 goes there. The negative can go with either one. It doesn't matter. Sometimes you might have to move it. So what's our angle? Across from 1/2. Pi over 6. But your answer, -pi over 6. You guys realize there's only so many of these I can ask you? Like I've probably done some that are on the actual test, like not even different questions because there's only so many problems. All right, now ones like this are the only ones you do not have to draw a triangle for. Do you see how this is tangent and arctangent? They undo each other. Now it only works if the inverse is on the inside. Do you remember me saying that? Inverse inside. So do you see how the arc one, that's the inverse, is on the inside? Tangent and arctangent cancel out and you literally just get 2/3. The only kind of question you do not have to show a triangle for. So see, same thing here, cosine, cosine inverse, or arc cosine, two different ways of saying the same thing. The inverse is on the inside, so they cancel, and you just get what's there, negative square root of 5/7. Now for this one, these do not just cancel out. Do you see how the inverse is not on the inside? You're gonna have to draw a triangle, and actually you end up with two triangles. What quadrant is 5π/4 in? Third. And so your angle is π/4, and your sides are square root of 2/2. Oh, but also they're negative. Now it says sine is the y value. Now they end up being the same thing, but sine is the y value. So this part I'm circling right here, this sine 5π/4 is negative square root of 2/2. So I'm going to uncover this with my finger. This is arc sine of negative square root of 2/2. And now you're back to a problem exactly like all the other ones that we did on this sheet. You are very restricted about what quadrants you can be in. It can't be quadrant 3. That's not even an option. For arc sine and it being negative, where's the other option? 4. Good. So what you're going to do is draw your triangle in quadrant 4, and you're going to recopy all of this information over there. It's the exact same triangle. It just gets reflected. But your answer is not π/4. Negative π/4. Good job. All right, so for this one, 4π/3 is in the third quadrant. Your angle is π/3. What's going to go across from that? Square root of 3/2. Other side is 1/2, and they are both negative. Now it says cosine. Cosine is which part of that? X, which is the negative 1/2. So this part I'm circling right there is negative 1/2. So when I uncover this with my hand, it's arc cosine negative 1/2. So you're very restricted. You can't have a triangle in quadrant 3. It's not even an option. Where is arc cosine going to be since it's negative? Quadrant 2. Now I wrote mine a little bit too big. If you had space, you could just draw the triangle up here and just reflect it all. I'm going to just draw a totally brand new triangle because I didn't have enough room. But you're just taking this triangle and reflecting it up. So it's all the exact same stuff. It like literally just recopy it, except the square root of 3/2 is positive. But your answer is not π/3. It is how far you rotated to get there. So the denominator is going to be 3. Good, perfect. You got it. See, we got there. Good job. All right, now these ones you're going to be using Pythagorean theorem and all that stuff. They're not on the unit circle. Do you see how that's just 4? I would put it over 1. Or actually, you know what? Let me just rewrite it, because a lot of you have responded better to that. Let me just rewrite it. Which function is the reciprocal of cosecant? Sine. So let's just rewrite it as arc sine. And if you flip 4, it's 1/4. I just reciprocated it. We'll do it that way instead, because I think a lot of you kind of liked that better. It's positive, which is great. That means we are in quadrant 1. And we're back to using words like adjacent, opposite, and hypotenuse. There's no y/x and all that stuff. It's, you know, opposite, adjacent, hypotenuse. So sine is opposite over hypotenuse, and then you're going to do Pythagorean theorem to get the other side. You guys are real quick with that. Like you guys, there hasn't been any problems with that. So what is that going to come out to? 15? I've seen that. So your answer would be square root of 15. So that's your quote unquote work. You don't actually end up having the angle labeled in these ones. If that bothers you and you're like, oh, I cannot leave it blank, something must be there. You could put theta just to fill it in. But that can actually be blank. We don't know what the angle is, to be honest. You just answer the question. It says secant. Secant is the reciprocal of which one? Cosine. Cosine is adjacent over hypotenuse. So this is gonna be hypotenuse over adjacent. So it is 4 over square root of 15. And then there's one more step. You have to rationalize it. So 4 square root of 15 over 15. That was a bunch of steps, but it was Pythagorean theorem. You guys can do that. I believe in you. This is negative and it's cotangent. So which quadrant is that going to be in? 4, quadrant 4. Cotangent is adjacent over hypotenuse. So the 5 is going to go here and the 12 is going to go here. Which one would get the negative? The 12, good. And this is one of the locker combinations. Do you remember it? So we don't have to do any more work. 5, 12, 13. Is that what you said? No? Okay. Well, then you would do Pythagorean theorem. Okay. Now I'm going to uncover this. And again, if you want to put theta in there, you can, or you can just leave it blank. It says cosine. Cosine is adjacent over hypotenuse. So 5 over 13. Those are nice because there's not any weird square roots. All right. And then these last two have u. It's the same exact process. We just don't know what that number is. You're going to need to put this as u over 1 so that you have something over something. I don't know what u is, so we're just going to assume it's positive. Just put it in quadrant 1. Tangent is what over what? Yeah, it's opposite over adjacent. So that's where the u and the 1 goes. And then do your Pythagorean theorem. We had just called it X, the thing we're looking for. You can call it C. You can call it whatever your heart desires. You can call it R. It doesn't really matter. But here's where people go off track because there's a U and there's an X. Which one are you trying to get by itself? X. Okay. So that means you're just going to square root both sides and please do nothing. Do not cancel anything else. You can do 1 squared, which is 1, but please leave that alone. It will be square root of 1 plus U squared. Those don't cancel because it's one whole thing. You can put parentheses around it if you think that'll help remind you, but don't cancel any of that out. Yep, go ahead.
Do the square on the line.
Leave it 1 squared. I can't fault you for that because it technically means the same thing. All right, and then we're going to do cosine of that. Cosine is what over what? Good. Now this is going to look really weird. It's adjacent over hypotenuse. And you have to rationalize that. So it is going to be square root of 1 plus u squared over 1 plus u squared. I get that it looks awful, but it's the same process. It's just what you ended up with. It's fine. You're gonna be okay. Yeah. Oh, yeah, you can do that too. Like leave that 1 there. Yeah, those things come down to personal preference. That's like if you feel like writing it or not. All right, last one. I don't know what u is, so we're going to assume it's positive. Draw it in quadrant 1. Sine is opposite over hypotenuse. So 5 is the opposite, u is the hypotenuse. And then you have to do Pythagorean theorem to get the other side. So like this one, to follow up your other question, if you want to leave it 5 squared instead of writing 25, I technically can't mark that wrong. I mean, I won't like it as much because it'll look weird, but it's the same thing. All right, now are you trying to get X by itself or U by itself? X. Okay, so you would have to subtract this over. So it would be U squared minus 25 and then square root. Leave it alone. Do not change anything. Mathematically, like algebraically, you are not allowed to change that. And if you want to put parentheses around it to remind yourself, like if it was 2 separate things, you could, but it's all one thing. And then you're going to answer the question. Tangent is what over what? Opposite over adjacent. So it is 5 over that nasty square root. And so that would rationalize to be what? Of stuff, yeah. Over that stuff.